Okay, hello everybody. Today we're going to talk about the thin lens equation, and as you can see here below, what we're going to be talking about is a converging or a diverging lens and the following variables. So DO, which represents the distance from the object to the optical center, DI, which is this distance here, the distance from the image to the optical center, and then finally F, or the focal length of the lens. Okay, the other couple of variables that I mentioned here are the height of the image and the height of the object, which relate to magnification. So it tells you whether or not the lens makes the image larger or smaller than the object. Okay, so here we have the equation, which is 1 over F, or 1 over the focal length, is equal to 1 over the object distance added to 1 over the image distance. So a little way to remember that would be if I do, I die. All right, so a couple things that we need to do to remember to use the thin lens equation properly is to follow the following conventions. Okay, so one thing to keep in mind is that object distances, so the object distance from here to the lens, is always going to be positive. Okay, when image distances, so this distance here, is forming a real image, it's going to be represented by a positive number. Okay, so when the image is actually formed by true rays of intersecting light on the opposite side of the object to the lens, then it's going to be a positive number that we're going to use. Okay. When we get a virtual image, so in the case of a diverging lens, or in certain cases if we get inside the focal length and the image appears on the same side of the lens as the object, and it's virtual, we're going to say that that is a negative number, just to represent that it's on the same side as the object. Okay? When we have a Okay, good evening everyone. Tonight we're going to learn about the thin lens equation, and we're going to talk a little bit first about the variables that are involved in order to understand a little bit more. Okay, so an image like this, we get a real image over on this side, and this distance here from the object to the optical center would be represented by DO. Okay. On the other side, we've got DI, or the distance from the image to the optical center. Okay, another thing that we're going to look at is F, or the focal length of the lens. And here I've mentioned HI and HO, which just simply represent how large the object is and how large the image is, which is important when you're talking about magnification. All right, so here's our equation. So 1 over F is equal to 1 over DO, or the distance of the object, added to 1 over DI. So this is just a simple way to relate to the focal length, the distance of the object, and the distance of the image when we're talking about lenses. All right, there's a few things to remember before we go any further, and that is that the object distance is always positive. So from here to the lens is always going to be a positive number. When we're talking about a real image, such as this picture here, if it's a converging lens, so where the light actually intersects and the image is formed on the opposite side of the lens than the object, we use a positive number to represent a real image. If we're using a diverging lens, or if we're inside the focal length in a converging lens, what we're going to get is a virtual image. And to represent that, we're going to use a negative number. So when we get the image on the same side as the object, make sure you remember to put a little negative sign beside that number. All right, and lastly, the focal length will be positive for a converging lens. So if you remember, the light all focuses on the opposite side of the lens, and negative for a diverging lens. So when it's over on the same side as the object. All right, that's pretty much it. And now I'm just going to show you a sample calculation or sample problem here. So here's our problem. we've got, let's say, a converging lens with a focal length of 17 centimeters. So that's going to be on the opposite side of the lens. And if we put a candle 48 centimeters from the lens, what type of image are we going to get? And where is it going to be located? So you could find this out by doing the experiment, but if you're just curious and want to know, we can find that out. So the given information for us is that it's got a focal length of 17 centimeters and an object distance of 48 centimeters. So let me just fix this. That's not negative, it's just equal to. And we're using a positive number because the object distance is always going to be positive. And I'm using positive 17 because we're talking about a converging lens. All right, so what are we looking for here, or what's required is DI, or the image distance. So we want to know where that's going to show up with relation to the lens. All right, so here's our equation, our little if I do, I die. And the trouble is we're going to have to rearrange this and bring it around because we're not solving for F, the focal length. We're looking for this DI. So we're going to have to take away 1 over DO from 1 over the focal length in order to set that up properly. All right, so now that we've got that set up, so here's our 1 over DI equals 1 over F minus 1 over DO. We're just going to start filling everything in. So 1 over 17 centimeters of the focal length, subtract 1 over 48 centimeters. Okay, so don't worry about it being a fraction. Just plug it into your calculator and subtract one from the other. So what you're going to get is 1 over 0.038 centimeters, which is equal to 1 over the distance of the image. So we want to actually know where the image is. So what we have to do is take the reciprocal, or 1 over 0.038, to give us DI. So to represent that, I've just said to the negative 1, which means 1 divided by 0.038. So when you punch that in, what you're going to get is an image distance of 26 centimeters. So that's telling us it's a positive number, so therefore it's going to be a real image, and it's going to be on the opposite side of the lens, 26 centimeters away. And we're going to get a little upside down candle. All right, hopefully that helps. Thanks very much.